All right. Hello, everybody. We need to have a little talk. So, you guys are all trying to up tier in like doing your small ISPs and things like that, or maybe you're a larger ISP. You've grown to that point, but there's certain things that you need to know. I like to consider myself pretty well versed in power systems. That's my background. I literally went to college for electrical systems, not just electrician, but DC plant, off grid, all that stuff. That was my thing. Okay, my major, I guess you could call it. Can you call it a major in college? I don't know. Anyway, I went to Seneca for off grid and renewable systems. So, the reason why I'm doing this video is server specific, because a lot of you guys are starting to get into loading your own servers, and you're loading them in the field. You're not loading them in data centers, or maybe you are, but the point still stands is that you need to make sure that you've got proper power management if you're using anything like a server. Main purpose being is that if you've got a little server and it's running any kind of database reliant applications, and the power shits the bed, you know what's going to happen? Databases are clunky. They're kludgy and bulky and shitty, kind of like Red Hat. And so basically they run in the memory, kind of like Red Hat. And so what ends up happening is that if you've got something running in your RAM and you just cut the power to it, it's going to dump the memory, right? And there's going to be a lot of stuff that might not make it back to the hard drive, which is one of the reasons why servers typically also have little battery packs on the RAID controllers, is so that any activities that were active, any actions that were active during the power failure will actually remain in memory until the server comes back up. Hold on a second. I think I caught cold. Oh, this is horrible. I got one of those sneezes, and it's like right up here in the sinus, and like I need to sneeze, and it would be so satisfying, but it just pulled back. It's just like, oh, fuck you, sneeze. So anyway, let's take a look at a few things. So first of all, again, the context of this video is about installing servers or sensitive equipment that requires AC in the field. So this would be anytime that you've got a cabinet out in the field that has environmental control, that you've got like a server in. Okay, this is specifically what we're going to discuss today. I will touch on like data center stuff as well. So there's lots of companies out there that specifically work with this. Okay, you've got like Delta, you've got Alpha, you've got I believe ICT does it. Lightsaber's starting to get into this too. You've got I think Minuteman does this stuff too. You've got Emerson, you've got Eaton. Why haven't I yet mentioned APC? Because APC, it's kind of like the lower mid tier when it comes to any kind of like data center related stuff, right? And we're talking about telecom specifically. And when we're talking about telecom, we're talking about equipment that's hardened against. I'm not going to edit that. We're talking about equipment that is hardened against crazy environmental factors like high temp, low temp, surges, spikes, water ingress, high humidity, rat feces, like all that stuff, right? So that's where this stuff is critical. And that's why, by the way, I'm starting this video parked on the Alpha page, because Alpha have great solutions for the majority of your applications. But I digress. Let's go to the first solution I would personally choose. Okay, so you've got a Dell, HP, or Supermicro server. Those are the three examples I'm choosing. But the majority of these companies typically use common off-the-shelf power supplies. It's not like HP goes out of the way to manufacture a power supply from scratch, or Dell manufactures. No. They use like Meanwhile or Delta or various other companies that already have power supplies on the market that suit their needs, or they might request specific modifications made to them, and then they have the sleds, are the sockets. We can call it a server vagina, whatever, that accommodate that power supply. They design a platform, or the company like HP or Fujitsu or Supermicro actually design a sled or receiver that around a power supply that's already existent on the market. And for that reason, we've got some cool shit out there. So now let's go to the solution that I would choose, okay? So first of all, if you're going to put a server in the field, you're a brave individual and make sure you get something that's hardened or a smaller embedded server. Supermicro have some nice stuff like that. Otherwise, let's take a look at this. Okay, so let's look at Dell. Look at what you can buy for your Dell. All right, so this is a Dell DC power supply. So this is a god-awful picture, but essentially you can see the DC port on it right there, and it says right there, Dell PowerEdge 15th Gen 1100 watt 48 volt DC power supply. I just picked one at random. If you go on eBay or contact, if you have the money, when you're ordering your server from whoever, you can usually ask them if it's a like a vendor like Cynix. You can say, hey, by the way, I need 48 volt power supplies for this thing. And they're like, okay, now there's a 50-50 chance that the vendor that you're buying from might be like, what do you mean DC power supplies? Because I've noticed that, you know, society as a whole is crumbling and going to hell. Or if they're experienced and good at their job, which is what we should hope for companies like that, fluff. They'll say, okay, well, how many watts do you want? Do you want 500? Do you want 1100? How many watts do you require for your power supply? I'm going to suggest this because I know this server. So here's an example of a Dell. Wow, that's obnoxious. This is an example of a Dell DC power supply that you would just slip in to replace the power supply that's in it. Let's look at an HP. This is a better example. So this is used. This is a used one off eBay. And usually the worst thing that happens to these power supplies is either they get water contamination or literally rodent urine contamination, or capacitors wear out. But I mean, like, we're talking about newer servers anyway, and the chances that the caps are worn out is pretty slim. So just go on eBay if you want and you don't have the money to buy new. So here's an example of one for a HP, okay? 750 watt, 48 volts DC, all right? Now let's take a look at one for a Supermicro. Can you, like, not? Can I just... There, thank you. This is a Supermicro power supply, which, by the way, looks oddly similar. Let me just grab my Sun Microsystems power supply. 1 second. Wow. That does look oddly similar to my Sun Microsystems power supply. Actually, look at that. Look at the pins on this. Now, who makes this power supply? This is a Delta power supply. Holy crap! That's why they look similar. As this Sun Microsystems power supply is literally just a Delta off the shelf. As you can see, Supermicro, again, I'm going to bring up the pins here so you can see it. The modification that they've made on that Supermicro is that they've got an additional fan here to increase the amount of volume, air volume, but I mean, it's literally interchangeable. Yeah, you've got your, see the top of those two pins there? The top, I believe, is negative, and the bottom of those pins is positive 12 volts. All this is just a 12 volt power supply, okay? This is all your APM stuff. So this is the interfacing and sensors packs for these guys, okay? I don't want to talk to you. Go away, shoo. All right, so there you go. So, I mean, like, we're looking at this right now. Let's see if it'll actually say Delta on it. How about go away? There we go. No, but there's definitely a lot of Chinese on that, which means that you might not be able to use it in the United States. Oh, I went there. Yeah, be careful, guys. Before long, your government's going to wake up and realize that, I mean, like, pretty much everything's made in China, and if it's not, then this is going to cost 20 times as much. But anyway, I digress. Let's see, is this actually the same power output as well? 54 amps, that is 53.28. 3 amps on the 3 volt bus, yep. And 650 watts, 658. Yeah, I'd wager that this is literally the same power supply, and this might actually be made by another company that's not actually Delta. This could have actually been, both of these power supplies here might have actually been white labeled by another company, yet again. So the point that I'm getting at here, I'm going to digress here, is that the first things first, is you should be able to find a 48-volt power supply for your server fairly simply. If you're a small company, look for one used on eBay or Craigslist or Grindr or whatever. If you have the money and you're spending money on servers that you're going to have for a while, you can order them with the appropriate DC power supplies. And if you're buying used servers and they're modern servers and not like, like something from like 2000, chances are you can probably contact the manufacturer or a vendor that specializes in that specific product and order the power supplies brand new for it. So there's your options there, okay, for converting your servers to DC, which is going to be a good thing if it's in the field. So now let's talk about situations where you absolutely must have AC, okay? And this is going to be very important as well, all right? Because I'm going to get into some key points that I didn't mention with the DC power supplies that you have to take into consideration when you're running servers. You remember I mentioned the whole thing about if you've got any kind of databases like Mongo or Oracle or whatever running on your server. Remember I mentioned that earlier, right? Like, it's in the memory. Oh, your database is corrupt. Oh, your whole fucking thing's pooched. You're fucked, right? Nah, okay, you want to avoid that. So I'm going to show you something which you're going to see in common with a lot of these servers. You see how it's got an Ethernet port? You see that card right there is a very specific and diverse card that you will find in most Eaton products. In fact, if we go back over here, you will also see that there are 2 Ethernet ports on this guy. And because this is a literal telecom grade power inverter right here, right? You have a lot of different relay packs, like you can have relays on here and sensors, okay? Now let's take a look at, let's see here. Did I bring up, I've got Eaton and Alpha. I don't think that I brought up the Emerson stuff, but you know what? This is good enough. So if you're going to be using any kind of UPSs or telecom grade inverters, use something reputable. Triplite, stay away from them. I mean, Schneider did, or sorry, what? Eaton bought Triplite, but honestly, I've had nothing but problems with Triplite. I know that some of you guys will disagree. Good for you. You've had good luck. Hey, it's exactly the same thing with a Ford. I've, knock on wood, never had problems driving a Ford vehicle. Others will say the opposite. The fact of the matter is, though, I know from a manufacturing standpoint that Triplite is mostly cheap. In our field, you should be using, at the very least, Eaton, maybe Emerson, and then from there, just go up. You're going to be looking at proper enterprise or data center quality equipment, okay? So in all of these cases, you're going to notice that the power supplies actually have a Ethernet port on them, or they've got a USB port on them, okay? So why is that important? See how it, well, this kind of gives it away. Look, USB serial. The reason why this stuff has this is because, I'll show you an APC cable here. You've probably seen one of these APC cables before. This is for a cheap back UPS cable, okay? What this allows you to do is connect your server to your power supply, or your inverter, or your UPS. Ultimately, they're all UPSs, right? The purpose for this, whether you're directly connecting via a serial or USB port, or whether you're using an Ethernet-based client, which uses a server that's embedded inside of this, most of these guys are compatible with what's called APC UPS daemon. I've got another video following this one. It's like 11 o'clock here right now. I'm tired. I feel like shit. But my intention is tomorrow is President's Day in America, and it's some kind of a holiday here in Canada. So I've got my server sitting over there with the UPS, and I'm going to do a full server load for you guys, including setting up the UPS on it. Okay, so now let me digress yet again. Why should you, and you should, connect your server to your UPS with comms as well as power? Let's think about that for a sec. Oh, some of you already knew the answer to that. I know you did, because I smelled something burning. So, I mean, you guys were definitely cycling up. You know, your duty was hitting about 80% there. So, yeah, why? Is because you can set parameters very simply, even with APC UPS daemon. Or in Windows, if you, for example, I'm going to use Windows 10 as an example, which is not a server operating system. I'm on a laptop right now. Look at the bottom corner here. See this? You see how that's showing me power stats? Okay? That's very simple polling, okay? And if you take a regular desktop computer and connect a UPS to it, which you might have, If you actually did connect the USB cable, which you should, you're going to see this. It's basically allowing the OS to communicate with the UPS. And what that allows you to do is, yeah, sure, you get the idea of how much power you've got remaining and whatnot, right? But the more critical point is that if power is lost and the storage source, be it batteries or whatever, is starting to become depleted, it's reaching the point of depletion, you can already figure out how long your server takes to shut down. You really should do that test. For example, with Proxmox, which is my favorite, you need to install QEMU guest agent and all of the VMs that are running on it, okay? That allows the VMs to communicate and have sensor interfacing between the actual VM itself and with the host OS of Proxmox. So in that case there, if you actually click shutdown on Proxmox, it should shut down. It's almost like pushing a power button on all of the VMs running on that Proxmox node, okay? So now that ties in with this. So you've got your big chunky boy here, your power supply, you got your Eaton over here, whatever, right? And your batteries have reached about 20%. So you know that you've got roughly about an hour left of your batteries. Okay, well, it's time to shut the server down. All right. Now, I'm just arbitrarily picking numbers because obviously you can gauge your runtime based on the demand at your data center, okay, or at your field cabinet, okay? So what you want to do is you want to actually configure your server so that if the power is depleted, whether again it's over Ethernet or whether it's over direct USB interfacing, it will receive the signaling from the UPS. The parameters that you can set in APC UPS daemon are very simple, or in Windows you can literally just, there's characteristics that you can program in here. I think you can do it right here. You can tell it when to shut down. Let's see, turn on battery saver, turn battery saver on automatically at, come on, ADHD'd out for a second there. So you can actually set when it's going to knock it down, basically. You've got all of your parameters right here. So the point is that you should set your server so that when your batteries are nearly depleted, the server will shut itself down, okay? Now, what that's going to do is that is going to allow for a graceful shutdown of the server, which means that you're not going to have to worry about your databases being corrupted or any kind of damage to any of the software that's on there or loss of information, okay? This is going to save you so much bloody misery. Now you're probably saying, well, that's stupid, because what if my server shuts down and then the power comes back on? Well, that's going into something entirely different, which we're going to talk about in my server setup video, which is some people call it ILOM, some people call it iDRAC, depends on the vendor and the flavor, right? But other people call it lights out. Basically, most servers actually have an internal KVM, and many good companies don't charge additional licensing fees to use it. And what that is there is an Ethernet port that you can plug into for out-of-band management of just the server chassis, not Proxmox or VMware or Hyper-V, God forbid, or QEMU or whatever it is that you're using to host your virtual machines, okay? So if the power depleted and the server decided to shut itself down, you still have direct access to the lights out module, which means that you can literally, it's almost like being physically in front of it. You literally just log into that and just click power on. It'll power it on. Another thing what you can do is in the BIOS of even desktop computers now, you can have power up on power restore or on power restore. There's different terminology for all sorts of different systems and whatnot. But the point still remains is that what it'll do is when the server sees power return, even if it shut itself down, when the power comes back up, it will turn itself back on. The problem lies there is that if the UPS never fully shut down and the UPS never fully shut down and power comes back on, the server is going to be sitting there offline. But again, going back to what I said a minute ago, you can still log into the server's lights out or remote console, which is a pretty little GUI, and you can click power on and you can turn it back on. There's also parameters which you can add with with a lot of UPSs actually. Like, I haven't worked much one-on-one with the alpha stuff, but I mean, like, with this stuff here, it'll have a software suite for Linux and Windows and everything, right? So the idea here is that you can also install their software on there, right? And so you can actually have wake-ups. Now, the other thing you've got here is you've got relays, okay? So you can actually tie the relays here into a trigger port on your server that will bring the server up when mains is restored, okay? There's all sorts of different ways, different mechanisms you can use. You can even have the lights out interface with this as well, so that when the power comes back on, mains is restored, it will automatically push the power button for you. There's a million ways to do this, and this isn't a tutorial video on how to do that. This is an explanation as to why you should be properly interfacing your field servers with their power equipment appropriately, okay? So I've shown you guys all this stuff. Yes, I love Eaton. I love Alpha. That's great equipment. So now, in the next video, when I actually do the load, I'm going to be loading the server. I'm going to be setting up APC UPS daemon. I'm basically doing one of the more simpler configurations so that you guys have an idea. What else should I be saying? I've got 20 minutes in here, and I think I've expressed my point well enough. To summarize, when you hook up a server, if you're not using DC power supplies in said server and you're hell-bent on using a UPS, one, use a reputable brand like Eaton or Alpha or Emerson or something higher end. You want to stay away from Triplite. You want to stay away from APC. You want to stay away from things like CyberPower is good, but I feel like CyberPower is specifically more for ASIC, right? It's specifically for, like, for example, I've got a Nokia NID under my desk here, and it's got a CyberPower power supply running it. I don't have a lot of experience with CyberPower to say if they're good or not, but I do know one thing is that once you start getting up into Eaton, Alpha, Emerson, you're getting into data center quality, you're getting into telecom grade. And more specifically, if you're using stuff out in the field, this is designed and hardened for that. So you want to use the appropriate UPS, and you want to make sure that not only are you receiving power from said UPS, but you have comms interfacing, and you have definitely configured the server to recognize the UPS and pull it. And the reason, again, why you do that is that the server will shut down gracefully once you've nearly depleted your standby power supply, okay? That will save you data loss. It'll save you database corruption. It'll save you equipment damage and all that wonderful stuff. So you just try to practice that, okay? I mean, routers and stuff, most routers, they're okay with it. They'll take a lot of BS and be fine, right? So that's all I've really got to say to you guys. All right, so yeah, you can skip this video if you want, but I'm really hoping that it was insightful and explained, why we're doing things a certain way, okay? I don't really have much more to say about that. Now, when it comes to the 48-volt power sleds that you put into your, or power supplies that you put into your servers, honestly, I've never used them. I know that they're there, and I would prefer to use them, but I'm not exactly sure at this point. One of you guys might be familiar with them and worked with them before, and if you have, please, in the comments below, link us to an article or explain in detail how that works, because I'm going to assume that when you're using a 48-volt module that there will be some sort of LVD mechanism or an additional sensor that you can pull in the OS to see what the battery status is, and you can set a low voltage disconnect point, an actual parameter in it that'll say, oh, well, we're running on 48 volts, that's great, but once you get down to 44 volts, yeah, it's time to shut ourselves down, okay? Yeah, I think I've said everything I need to say. I think I've covered everything I need to cover, and if I haven't, put it in the comments below. And don't forget to like and subscribe, tell your friends, and if you really want to help feed me, there's a Patreon linked in my channel somewhere. You can contribute a little bit of money to me. I'm going to continue trying to put out useful content for you guys. So, excuse me. I'm also going to try to keep it entertaining. Not that dry bullshit, So anyway, I hope that you took something away from that. Oh, yeah. By the way, notice, ATS. There's ATS right here. Ha ha ha, that's not cool. All right, so anyway, ciao, guys, and yeah, go forth and reproduce. Whatever. Bye.